So head scab is not the only disease facing our growers, and quite often growers ask the question, if I target head scab, am I losing yield because I'm not controlling leaf diseases? Typically, the recommendation for leaf diseases is apply that fungicide early, before that anthesis or heading growth stage. That's when you see the best control of some of our most common leaf diseases like Staganospora, Septoria, and powdery mildew. But what we've seen in my trials and in Ohio in general is if you target that fungicide to control head scab, you can still get very good control of leaf diseases. The idea behind controlling leaf diseases is to protect the flag leaf. You might not get as good control of the lower leaves, but those lower leaves are not contributing as much to grain yield as the flag leaf. And what we've seen in these trials, for example, you've got one trial here where a fungicide was applied targeting head scab, in other words, at that anthesis growth stage, no fungicide was applied. And if you look at the leaves, the flag leaves, on the plots that were treated for head scab control, you got decent head scab control as well as decent leaf disease control. So if you've got to make a decision as to whether to apply early or wait to apply that fungicide at the head scab timing, my recommendation at this point would be wait for the head scab timing, because you're going to get head scab control and good leaf disease control. Compare these two plots, you can see the difference. If you apply early for leaf disease, you're not necessarily going to get good head scab control. Even if you suppress head scab a little bit, vomitoxin levels are still going to be high. So in this particular trial, what we're doing here is looking at, we're trying to develop models that can be used to predict leaf diseases. And by leaf diseases, I mean Septoria, I mean Staganospora, I mean tan spot. This is a project funded by the USDA, an initiative called the National Predictive Modeling Tool Initiative. And basically, just in a nutshell, what we're trying to do is see if we can measure spores in the air and relate spores in the air to disease in the field. So what we've got here in front of me are spore samplers. These are cheap, low-budget spore samplers. And we've got a Burkhardt spore sampler as well. And what we're doing is collecting information, collecting spores in the air at weekly or 2-week intervals at different heights within the wheat crop. And then we quantify these spores using PCR-based methods to say how much spores we've got in the air at a given time throughout the growing season. What we also do out here is collect weather information. We try to correlate spore levels in the air to weather conditions, and then correlate those two factors to how much disease in the field. So we've got varieties here that are susceptible to Septoria, varieties that are resistant to Septoria. We walk these fields, we quantify how much Septoria we've got on the leaves, and then we relate Septoria on the leaves to spores in the air, to weather conditions, and we use that to predict disease levels. Again, the idea always in most of these projects that I do with developing predictive models is to give growers a head start. If we know that we've got high spore density in the air under these conditions, then growers can use that information to say, hey, I probably need to plan to apply a fungicide. I need to plan to use my best resistant variety. The idea here again is to give growers a head start in terms of estimated when the risk of disease is going to be high, so that it can make timely and economically sound fungicide application decisions.